Beautiful. So we can now start by sharing the screen. So last week we introduced VPC as virtual private cloud. And then we made ourselves to understand that VPC is like we having our own plots of land, taking steps to want to fence it, building our own house in it in the cloud. So that's how it works. So we talked about some services found in the VPC, the virtual private cloud. I introduced the subnets, and I said subnets are a kind of divided way we divide, segment this VPC from either private or public. And we talked about the CIDR block. We talked about the route table, how the network is routed from one area to another. And we also introduced the gateway, the internet gateway rather, which enables direct access to the internet. And we also introduced the NACLs, that's the network access control list, which would use in controlling inbound and outbound traffic into the subnet. And we talked about the security group as also a virtual firewall for the instance. Now the network access control list and the security group, what they are similar in the kind of job that they do, but the NACL is for the subnet level, while the security groups are for the instances in the subnet. Can you see? So these two things are part of the cloud security services, things that we're supposed to understand in the NACLs and the security groups. In the security group, we would want to ensure that we pre-screen IPs that should be coming into the subnet before they can get in. And also any traffic that may want to leave the subnet must be pre-screened. If it is an IP that is not allowed, that IP, that it will not go out of it or come into it. But the security group is not like that. The security group, whatever that is allowed in is allowed out. Okay, we'll talk about the state of that. So that's why we'll say that the NACL, that's the network access control list, is stateless. So to say, whatever that is allowed in, it would not be allowed out. So it's stateless. Why? The statefulness of the security group, whatever that is being allowed in would be allowed out. So it's just like a parent who stays at the gate of his house, ensuring that no criminal comes in, and at the same time, the kids would not be allowed to go into the street maybe at night to play. Before they may pass, they would have to obtain permission from the parents. So that's what the NACL would do. But the security group would not do that. Anybody that is let in can be allowed out. So that's just the difference. We talked about the VPN and the direct connect. We talked about the VPC peering in a way that multiple VPCs can be connected together and communication from both ends can commence. So that's about the little aspect of the recap of what we did last week. But so today, I want us to go deeper to now start looking at them and how we can provision them and have an understanding of this property called the virtual private cloud we have been introducing. So let's take a look at a particular diagram coming. Let me be sure if that is what I want to show us. Let me come in. Okay, now I'll come to this. All right. If you can see my screen, that would be nice. Somebody can just say, yes, I can see your screen. Gary, who can see it?
I can see your screen.
Yes, Siemens, we can see.
Yeah, we can see.
Okay, beautiful. You see this diagram that looks very cumbersome is what you're going to be doing for your organization as a solution architect. This is a diagram that you would be able to put together for the engineers to go and provision. So I want us to take a look at it, see how we can understand it. Now, this is, you can see this boundary, like this is the world, the cloud of AWS. You see that? Now, this is the VPC, your own portion.
Times, not to interrupt you, but can you mute all of us?
All right, thank you for that. Let me get that done. Moment. All right. So that is that. The AWS world is what you're seeing here now. And this is the web outside it. So which means everything that happens in the cloud must be internet connected. So there must be a connection. And the way it is being represented in this diagram, your own portion of the cloud, which is called the VPC, it's found in the AWS cloud. Can you see your own boundary? This is your own plot. You see that? So now how do we now connect the services, the functions taking place in your own portion of land or maybe in your own property to the world? Is by introducing what is called the internet gateway. You can see the internet gateway here. This brings life from the outside world into your VPC. And right from the internet gateway, can you see a router? That's a route table. This route table directs the network to go to the appropriate directions that you want it to go to. So this route table is a network device that you have introduced here, connecting to that internet. And now right away, there is further subdivision of this VPC, which is called the subnets. You have your own property being partitioned into two major areas, and you call the very first one that is closer to the outside world the public subnet. Maybe that's the area that you would want the internet to get in first. And then you have the private subnet right inside. So if the public subnet receives the internet, there must be a way the public subnet will send the internet to the private subnet. That's where we now started introducing what is called the NAT gateway. Can you see the NAT gateway here? The NAT gateway is showing here now, moving the network right into another router, another route table. But we really want to give life to a particular guy, the server, the instance, which is the EC2 that is here. We want to direct network to the EC2, that is our server. Everything we have here is just to ensure that this guy is protected. Can you see the various security level? Now, for this instance that we have here, this private instance, can you see that we have a barricade and a fence called the security group? This security group is a security for this instance, not allowing a disallowed IP to get into it because data could have been saved in here, important data could have been saved in here. So, but this security group, like I said, is stateful. Any IP allowed would still go out of it. Aside this, at this subnet level, we still have another security layer. Look at this tiny line that we have here. And that one is called the NACL, the Network Access Control List. And that NACL is stateless. It screens everything that gets in here. And we still want to check for anything that will go out of it. Just like somebody who walks in a place, they search you before you get in and they search you before you get out. You wouldn't bring anything you should not be, working with inside the property land. At the same time, you're not allowed to take things out. So this is what the NACL would do. It's a security device. So we have this. But aside that, there are other things. We talked about the VPC peering. What if we want this VPC to have communication with other VPCs? What would we do? We now introduce VPC peering at the boundary, connecting this VPC to the peering. So this will enable connection between this our VPC to other VPCs. All right. Then we have lots of other things that we'll talk about. We can see the Amazon DynamoDB. Now, this Amazon DynamoDB, you can also see the endpoint here. When your VPC services in your VPC are being allowed to communicate with other AWS services outside your VPC, you now enable the endpoint. The endpoint gives you power to be able to communicate between services or functionality in your VPC with other services outside your VPC. So this is just the little explanation I could give to us. But when you see a diagram like this, it's in a single availability zone. There's what is called availability zone, which means if anything happens and this availability zone is brought down, we may not have a backup. So wisdom may want to cancel us to duplicate whatever that is happening here by creating a multi-AZ, that's another availability zone. The same thing that is happening here could still be, happening somewhere else. So if peradventure there is a crash or an hitch here, we know that the servers there would immediately be in use and our data would be protected. So that's about the multi-AZ. So at this junction, let me start introducing some other functionalities that you could be using as you continue with AWS. I hope I have them here, or else we would. All right. Did we talk about cloud? I don't think we did that. Let's see. All right. Let's talk about the concept of region, the concept of availability zone, the concept of edge location and cloud fronts. About 2 weeks ago, we were celebrating AWS coming into Nigeria to set up a cloud front for us. So let's see what it entails. So AWS region, like what I have here, is a geographical area where Amazon Web Services has established data center. And in this data center, we have multiple availability zones. And this region is totally independent of other regions. Talking about infrastructures, how they are powered, and the networkings. And they have lots of regions around the world. Why would they want to set up isolated regions? Just for them to enable low latency for customers. Low latency means instantaneous internet services. I haven't said that. So an AZ is the data center within AWS region, has been said. And this is also isolated from other AZs. That's how it's cascaded down to the edge location. An edge location is a part of the Amazon CloudFront Content Delivery Network, that's CDN. So these locations are distributed globally and act as caching endpoint for delivering content to end users. What does caching mean? Caching is a powerful word that solution architects do deploy every now and then. So caching is like you went in and make a request of a particular credential or a particular data from Port Harcourt here. And it took you maybe a slight difference of 5 minutes or maybe 3 seconds or 30 seconds to access that information because you went right into the repository where it's been saved to access it the very first time. So AWS looked at it and said, okay, now that someone had been able to go in and to fetch out this information, what if the person wants to get this information? Will the network be traveling from Port Harcourt maybe to California where the original information is stored before the person can access it? He said, no, let's get an edge location somewhere. So once the information comes, there will be snapshots of that information somewhere around this Nigeria. So instead of going right into California to fetch it, if the edge location is planted in Lagos, it will be Lagos. Wow, what a wisdom. And that is about it. That's the concept. You can have a better understanding of it as you start growing in the knowledge of AWS. So Amazon CloudFront is a content delivery network. A content delivery network service provided by AWS. It helps deliver static, dynamic, and streaming content with low latency. That's our watchword. CloudFront uses a global network of edge location to cache and what distribute. The cache is the saving of, so you will not be traveling further to the original where the original data is stored. So that's about that. And now the CloudFront supports various features such as SSL/TLS encryption, customer domain names, content comparison, and more. Yeah, it must compare content. So it will not be in the name of caching, given slightly different information to somebody without respecting the actual command that is being made. So that it must have that power to compare the differences and give the appropriate called information. So what is SSL? I think that will take us to the next slide. Let's see. SSL is secure socket layer and TLS is transport layer security. And they are cryptographic protocols used to secure communication over network, such as the internet. When we say cryptographic, we're talking about encryption. This enables the system to decode or to code the information because in transit, anything can happen. There may be a man in the middle cannibalizing it and then replacing it with other kinds of information. But if it's encrypted, it totally serves as nothing to the man in the middle. So let's go to step-by-step provisioning of AWS virtual private cloud. I hope the time would carry us to at least do 3 functionality in the VPC. All right, let's go this way and see. All right, okay, where is this phone now? Just a few seconds, we would be back. Just hold on. But if anyone has a contribution to make, you can kindly unmute. I said contribution. Kindly unmute and make your contribution. Any contribution? Are we connected?
Yes, sorry, Timex.
Yeah, we are here.
Yeah, I would like you to go over the NAT gateway and the internet gateway again as it relates to resources and network.
Okay.
Hello.
All right. NAT gateway and internet gateway. You want to see that slide from the diagram or where?
I want you to go over it again, like explain it in simpler things as it relates to resources and the subnets. You said something about internet gateway, making the public subnets accessible to the internet.
Yes, that is it. Just as you heard it. You can see this diagram. This is the internet gateway, right?
Yeah.
And the internet gateway is seated between the internet, the open world, and our VPC, right?
Yes.
So that is how it is. Now you see that the NAT gateway is inside the subnet. Can you see that? And
yes.
The NAT gateway is connected to the router, that is the route table that is connected to the internet gateway. So the NAT gateway, the work of the NAT gateway here now is to enable network to move down to this private subnet from the public subnet. All right?
Okay.
That
I guess my issue was I was of the opinion that NAT gateway is presence because resources from the private subnets. The resources from the private subnets will need to connect to the internet, and they need NAT gateway, and that's only possible if resources in the private subnet are sending outbound traffic to the internet. So,
but what you have said, is it different from what we have been treating? What you have said, I think. Okay, just okay. Go ahead. We are listening.
I was trying to know how traffic can get to the private subnets, like the security aspect
when you look at
getting traffic to the private subnets.
Yeah. So take a look at the diagram. Where else can you find a connection between the instances in the private subnet to the internet gateway? Follow the route. You will see that you're moving down like this, right? You may even look at it the way it's going out. Okay? It's still the same thing. It's connection. We have inbound and outbound, which means the same flow line can also take the same. It's just a route. Different route tables can maybe redistribute in different direction, but the connection must observe all these. When we provision it, you will understand it better. But I think you have an understanding of it. Maybe not a little confusion setting by the way I'm approaching it, right? Say yes. And
maybe. Maybe. Let's move on. Maybe when you provision it, we'll get it better. We get it better.
All right. So who else want to make a contribute, explain this better to him? Who is here?
No, let's move on. Let's move on.
All right. We may not be able to take all questions as we go because lots of all these can later be talked about. So let's go down. Like I said, you should not use your root user account. By now, you could have set up your IAM user account. So that's what you use in logging in. For everything you do, ensure that you use your IAM user account. See how fast is my internet. Okay, let's go in here and say in the search pane here. So now we want to now start setting up VPC. So the first thing is for all to check through the services and locate VPC. So we enter it. Try and pay attention and know the little that can help you to know the most. So having done this, you move to your VPC. All right. And you click create VPC. Now we have we have two options, VPC only and VPC and more. At this stage, I wouldn't want you to use the VPC and more because that would make everything, very seamless to you, and things that you're supposed to understand, you may miss them. So let's go the grassroots. So VPC. So we enter the name. So you can create a unique name. I'm going to use my own name here. All right. Okay. Let me use Tmex. All right. Then we go down. We will take our time to be explaining things, okay? So we would enter the IPv4 CIDR. There would be a class for us to understand CIDR and CIDR blocks and the way they are being used. But for now, what I want you to do, just enter.
Hello, Times.
to
Sorry to interrupt. This is Eric. So, before you log into your console, you said we should use the IMA user, but I saw you using the root user. You log in as a root user.
I didn't use the root user. I did not. I did not, okay? It's not the root, it's not the root account. The root was showing on top. I changed it. All right?
Yeah, okay. Thank you. Yeah.
All right, let's move on. So let's enter the IP, which is 10.0.0.0 0/16. Leave the
Hi,
no.
everyone.
Please,
Hello.
we would not be. Please, if you want to speak, you would raise your hands and you ask your
Please,
question.
is this
because
our laptop?
you will ask your questions later after the section. So for now, we would not be entertaining questions, you understand? So we can actually have a smooth ride to what we are doing. Just listen. And if you're confused in an area, you may have clarification in the future.
Sorry, teammates,
Thank
they
you.
can drop their questions on the comment section, boss. So it will be easy.
Exactly. It's okay.
So
Then we'll
later,
come back to them and
yeah.
then see how come back to them and see how we can answer them. Thank you. So you leave the tenancy at just the way it is at default, and leave the tag. Already your name is being taken as a value. So you create VPC. That is simple, right? This shows that we have just done this. This is what we've done. We've just been able to carve out our own portion of the cloud. That's what we've just done. So now I want us to now start creating and start adding subnets. But these subnets I want us to add, I want us to take a look at them from the perspective of multi-AZs. So we'll, create two availability zones. So we'll have public subnet A and private subnet B, all right, in a particular subnet and then in another one. So let's move on. Go down here. You can see subnet. So you click subnet. There's a default subnet showing here, maybe the same with yours. You now go to create subnet, and the VPC which we have created, we may want to attach it here. Even if we did not, in the future, there would be opportunity for us to reattach it. Okay. So let's see. It's already showing here as TMX. So I have it attached. Let's go down. So we have one of one. So now we can enter the name, which I want to say public subnet A for me. That is for me. Then the availability zone, we will take US East North Virginia. That's US East 1A. That is the AZ which we are taking. For the CIDR block, which you would be using, take 10.0.0.0/24. When you start working as a cloud engineer, most of these will be selected and be given to you by your management. But it's always good you know how it works. So we'll talk about them. We'll look for a class and treat CIDR and IPs. So what should we do? We create. If we create, but I don't want to create that. So let's add another one now. So you come here, you see add new subnet, 2 of 2. So the naming convention for this will be public subnet B. So let's go to 1B now. US East 1B. What will be our CIDR? Now you tweak it a little. Endpoint 0.1.0/24. Let's now start creating the private subnet. Let's go back to the very first AZ, which is US East 1A. So we've successfully placed 2 subnets in 1 availability zone. Or should we take as our CIDR? Let's say 10.0.16.0/20. So the second private subnet is needed. So let's add that for 4. That will be named private subnet B. So we go to the second availability zone, which is US East 1B. I haven't done this. We now create. Okay, the CIDR must be valid. That is for which of them? The last one, we didn't put it. We didn't enter it. Okay, let's ensure that we enter it. .32.0/20. Okay, let's create and see if all is well. Wow, this is beautiful. This is what we have here. Let's go to the VPC dashboard. So now, what is next on our list is the creation of this guy internet gateway. Okay, we are here. Let's come to, this is VPC dashboard. Under virtual private cloud, you would see internet gateway. Now we pick that guy. Yeah. So we have to create internet gateway. So same thing we're going to do here by giving it a befitting name. So let's say TMX IGW. Yeah. So we create. Okay. So you can see that is detached. It shows that the guy is not connected to anything. So we would try and see how we can have it connected. Okay, let me correct this name. It's not well spelled. So when you go to the action at your right-hand edge, once you have highlighted and have clicked the VPC, the internet gateway, you have to connect it to that very VPC that you want to route internet into by clicking on attach to VPC here. Now, TMX is rightly showing. So you pick the guide, boom, and you say attach internet gateway. Is showing attached now. It shows that we have successfully brought internet into the VPC that we created. Okay, there are lots of other things that we can do here to ensure that we have it being come and provisioned very well. But for now, we would have to keep our business simple. So let's move on to the next item. And I think after that, we can call it a day. Let's go on to create the route table. Let's go back to this dashboard. And you see your guide, the route table is showing here. Certain times I like to highlight the particular VPC that we are working on here by clicking this select a VPC. So let's see. Let's go to route table, click the route table. Okay. So let's create. You can see create. You say create route table. Let's go back to our diagram to refresh our memory of what we are doing. Oh, we see that there is a route table here in the public subnet and another route table here in the private subnet. So our naming conventions should rather take after that. So let's say, let's call this public public route table. Public route table. Right. Then the VPC, we go down to Tmex, is attached. Others will be remaining. You say create. We're going to repeat the same thing and create for the public subnet and for the private subnet. Let's go this way. I just hit on the route table here. Follow my cursor. I'm going down to create route table. This is our private, where we want to keep things like private. Only for the husband and the wife. That is for a few of us that are married. So same thing. You carry your VPC. And you create. Somebody might be saying, Tmex, you are too slow. All right, that I'm too slow, but it's okay. Just bear with me. If we get to where we can run, we will run. So you see the two guys seated here. Our public guy is here and our private is here. Wow, that's beautiful. But we still have to configure some little more things for us to associate it with the subnet. Okay, let's say we ally this guy. Coming. By entering it, you highlight it and you enter it. Under here, you will see routes. Can you see routes? You can see subnet association. You can see edge association. You can see route propagation and tag. So I want us to come to subnet association by clicking subnet association. Once you click subnet association, you move down to your right, you will see edit subnet association. Then you click. So now we have to click the public route table. Which we have done. So we want to pick the, I'm coming. This is the public subnet which we picked. So we're gonna take these two guys. Okay. And you save association. That is beautiful. We will go back to the private. Now this is the private. We've associated subnets to the public route table. Now we have to do the same thing for the private route table. Okay. Now, subnet association. Then we go down. We say edit subnet association. Now we are picking just the two private subnets. And we say save association. Here we are progressing. Now we would have to go to the route table. That is the public route table. We'll go back and do the same thing. We're already here, routes. You can see routes. We want to ensure that we have the CIDR block of any IP added to it. So you say edit by clicking here. So add route. What do? You enter 0.0, pick this guy. Okay. Now we're going to move in here and pick the internet gateway. You move in here and you pick the internet gateway. So you save changes. With this, you have just done what we have shown you on the diagram. Let's get to the diagram, excluding two more other things, excluding the NACLs and the NAT gateway. We have not provisioned this NAT gateway and the NACLs. the NACLs. The network access control list, we talked about this. So we're gonna call this a day. When we meet tomorrow, we will further provision the NACLs and see if we can pick any additional features to be added into our VPC learning pathway. All right, permit me now to stop the recording. Let me stop sharing first of all. Okay. All right.